Radical equations. The power rule. If both sides of an equation are raised to the same power or exponent, all solutions of the original equation are among the solutions of the new equation. Now let that sink in for a moment. Let's go back and find some key words. It says if both sides of the equation are raised to the same power or exponent, then all solutions of the original are going to be among the solutions of the new equation. In other words, you must check your solution. So in math, we know there are operations that work together, such as to undo addition, we do what? Subtract. To undo multiplication, we divide. To undo squaring something, we take the square root. And so, this is where the power rule comes into play. Let's look at our first example. 10 times the square root of 9x equals 60. Now, because this is an equation, we do want to draw a line at the equal sign. Alright, the first thing we want to do, we want to isolate the radical. Is there anything on the side with the radical that is not under the radical? Yes, there's a 10, so we need to get rid of it. It cannot stay in play. Since the 10 is touching, that means multiplication, so we need to divide. We divide the left side and the right side by 10, and it reduces to the square root 9x equals 6. Now that we have isolated the radical, it's time to use this power rule. So how do we use it? Well, whenever we read the problem, we said square root. Well, the opposite operation of square root means to square something, which means we're going to raise it to a power of 2. Now we can only do that if we do it to the left side and the right side. We have to be fair to the equation. Now the square root and the square undoes each other, leaving you 9x on the left side, but the right side, 6 squared, we know is 6 times 6, which is 36. From here, we have an x that's ready to be solved. We just have to know, is this linear or quadratic? It is linear, which means we need to get x alone. And so, next we need to divide the left side and the right side by 9, and we find x equals 4. But don't circle it as your final answer, because we're not sure if it really is. We have to check it. So on the side of your paper, we check our solutions. We go back to the original problem of 10 times the square root 9x equals 60. We find the variable x and replace it with the solution we think it is, which in this case we think it's a 4. And so we start to simplify doing gems. Well, under the radical we have 9 times 4, which we know is 36. Under the radical we know 36 is made up of 6 times 6. And since there is a complete set under the radical, we can bring that out and write it as 10 times 6. And 10 times 6 does equal 60, and so we have a true statement. 60 equals 60, which means x equals 4 is our solution. So now you can circle it or put a box around it. For b, we have the square root of 2x plus 15 minus x equals 0. Again, draw a line at the equal sign. From here, we want to isolate the radical, and notice on the side with the radical there is something that is not under the radical. So how do we get rid of subtracting x? Well, we need to add x to both sides. And when we do, we are left with the square root of 2x plus 15 equals x. Now that we have isolated the radical, we're ready to use the power rule. So again, because we're saying square root, that means we need to square the left side and the right side. So the square root and the square undoes each other, giving you 2x plus 15. On the right side, x squared means, well, x squared. So now that everything's laid out before us, let's see, is this linear or quadratic? Well, this one is quadratic. We know that because you see x squared. So the approach for x squared or quadratics is we have to get the equation equal to 0 and then we factor. Now since x squared is on the right side of the equation and he is positive, all the pieces need to go to that side of the equation. So we need to subtract the 2x and subtract the 15 from both sides. Once we've moved all the terms to one side, we now have 0 on the left, and so our new equation is 0 equals x squared minus 2x minus 15. Since our quadratic equals 0, now we're ready to factor. Remember, anytime you're going to factor, you always want to ask yourself first, do they have anything in common? In this case, they do not. So now you can move on into factoring into two binomials. So take the time now to factor. Hopefully you factored one binomial to be made up of x minus 5 and the other to be made up of x plus 3. Now we use the zero product property, meaning I have some number times some number equals 0, so one of those numbers must be 0 in disguise. Starting with the first value, we take that aside and we say x minus 5 equals 0. We solve for x by adding 5 on both sides and we get x equals 5. But we also have another possibility, which is x plus 3 could equal 0 or x equals negative 3. Now again, we cannot circle these or say these are our answers because we have to check. And because we have two solutions, we have to check both. So on the side of your paper, let's get ready. Square root of 2x plus 15 minus x equals 0. Every time you see x, we're going to plug in our first solution, which was a 5. We simplify, and then we continue to simplify as best we can. Square root 25 we know is made up of 5 times 5, which is a set, so it comes out of the radical. And 5 minus 5 does equal 0, so we do get to keep that solution. Now we have to check the other solution. So again, you go back to the original problem. For every x, you plug in our other option, which was a negative 3. And we simplify. Now notice, outside the radical, we had a minus sign, but minus negative 3, there is a sign change and makes it into a plus 3. We reduce under the radical. 9 is made up of 3 times 3. We do have a set, but 3 plus 3, does that equal 0? No, which means because that is not a true statement, we cannot keep that solution. So in this case, although we solved and we found 2 of them, only one of them is the real solution. See, we have the square root of x minus 5 equals negative 1. Again, draw your line at your equal sign. First step, isolate the radical. Lucky for us, it is already isolated. So now we move on to using the power rule. Since we read this as the square root of x minus 5, that means we are going to square the left side and square the right side. The square root and the square undo each other, giving you x minus 5. On the right side, negative 1 squared means negative 1 times negative 1, which we know is 1. From here, is this linear or quadratic? Linear, so we need to get x alone, which means we will need to add 5 to both sides, and we find x equals 6. In the last step, you have to check. So on the side of your paper, you go back to the original, and every time you have x, you plug in your solution. So we plug in a 6 under the radical. Under the radical, 6 minus 5 we know is 1. If we factor 1, 1 is made up of 1 times 1. we do have a set of 1's, so it comes out of the radical, and we have the equation 1 equals -1. Is that true? No, that's false, which means I cannot keep that answer. Do I have a second answer as a backup? No. So what do we put as our solution? Well, we use the phrase no solution. Now, here's something I do want you to notice. Look back at the original problem. It says because the index was an even number, such as square root, the result should not equal a negative number. Let's look at it this way. Remove all the work. Look at the original problem. Square root equals a negative value. If you ever notice that from the beginning, and it's an even index and it equals a negative value, you can immediately go to the phrase no solution. D. We have the cube root of 5x minus 2 equals -3. So first, draw your line. From here, we want to make sure that the radical is isolated, and lucky for us, it is. So now we apply the power rule. In this case, we have the cube root of 5x minus 2. So since the index is a 3, or it's a cube root, that means we are going to cube the left side and cube the right side, or raise both sides to a power of 3. Now the cube root and the cube undo each other, allowing 5x minus 2 to be free of the radical. On the right side, -3 cubed means -3 times -3 times -3, which we know is -27. Now that everything is free from the radical, we must decide, is this linear or quadratic? Well, it is linear, so we need to get x alone. The first step to doing that would be to add 2 to both sides, which now gives us 5x equals -25. The last step to get x by itself is to divide the left side and the right side by 5, and we find x equals -5. Now, we have to check. So, on the side of your paper, we show our work. We always start back at the original equation. Cube root of 5x minus 2 equals -3. Replace the variable with our solution, which we think is -5. Under the radical, 5 times -5 is -25. Under the radical, we can combine, which gives us -27. Now we want to factor that. What number times itself 3 times could possibly give you -27? Well, we can rewrite it as -3 times -3 times -3. And notice we do have a set, so it can come out of the radical. And now your statement is -3 equals -3. Is that true? Yes. And since it is, it means we can keep our solution of x equals -5. Now, I do want to note something. In this case, because the index was an odd number, the result could equal a negative number. Meaning, let's take the work away and look back what this says. Because the index was odd, a cube root, it is okay if the result was a negative. For E, we have the square root of 6x plus 7 minus 2 equals x. Again, go ahead and draw your line. First step, we want to isolate the radical. To do so, we need to add 2 on both sides. Now that it's isolated, we have the square root of 6x plus 7 equals x plus 2. From here, because we have a variable trapped under the radical, we will need to use the power rule. Since this is a square root, it means we do need to square the left side and square the right side. Well, the left side, the square root and the square undoes each other, giving you 6x plus 7. But on the right side, x plus 2 squared really means x plus 2 times x plus 2. Now, because we have x plus 2 times x plus 2, go ahead and take a moment now to multiply that and see what you get. Okay, hopefully your equation now looks like 6x plus 7 equals x squared plus 4x plus 4. Now let's decide, is this linear or quadratic? Well, since there is an x squared, this is quadratic, which means set equal to 0 and factor. Now, since x squared is on the right side of the equation, all terms need to come to the right side of the equation, which means we need to subtract 6x and subtract 7, which now your equation turns into 0 equals x squared minus 2x minus 3. Now that it equals 0, we need to factor. Take a moment now to factor. Let's see what you get. Hopefully you factored one binomial into x minus 3 and the other is x plus 1. Since we have our two binomials, let's solve them individually and see what we find. X minus 3 equals 0 allows us to find x equals 3, while the other one is x plus 1 equals 0 or x equals negative 1. Now again, we don't know if these are both our answers, so we have to take the time to check. So on the right side, take a moment now to check both of your solutions. Okay, let's see. Should have plugged in your values for every time you saw x, simplified under the radical, pulled out any sets, and notice 5 minus 2 does equal 3, so you can keep that solution. You should have checked the other one as well, simplified under the radical, found any sets, and 1 minus 2 does equal negative 1, so you could keep that one as well. For f, we have the square root of 5 minus x plus 2 equals 8. This is your try it problem. Let's see. You should have drew your line. First step, isolate your radical by subtracting 2 on both sides. From here, because it was a square root, you should have squared the left side and the right side, which gave you 5 minus x equals 36. Noticed it was linear, so get x alone. Probably subtracted 5 on both sides. Found not x, but negative x equals 31. You need to get x completely by itself, so divide the left side and the right side by negative 1, and you should have found x equals negative 31. But you also were supposed to check. So again, back at the beginning, you plug in a negative 31 for x. Notice 5 minus a negative 31 changes to a positive, which gives you 36 under the radical, which is made up of 6 times 6, and since we do have a set, it comes out, and 6 plus 2 does equal 8, so you do get to keep that solution.